Pythagorean applications. Solving real-world problems involves identifying the information you know and determining how to use it, and use math to find the answers you need. So when the problem includes right angles, the solution may include the Pythagorean theorem as well as other math you've learned. So for example, here we have a square banquet room that measures 49.5 feet diagonally from corner to corner. What is the length of each side of the room rounded to the nearest foot? Now we know that a square divided diagonally in half is made of two equal right triangles. See, there's the little right angle there and the right angle there. And we know that this long side is the hypotenuse and it's 49.5 square feet. So we have a right angle and the hypotenuse. We're probably going to use the Pythagorean theorem, but for the Pythagorean theorem, we usually need to know two sides, and we're only given one, the hypotenuse. We don't know side A, and we don't know side B. But this is a square, so sides A and B are equal. So in a way, we do know two sides, and we can use the Pythagorean theorem and algebra to find the answer. So we're going to start by writing the formula c squared equals a squared plus b squared. We know that c squared is 49.5 feet squared. We don't know a squared, but we know that a squared and b squared are equal. So we could just put a squared plus a squared because they're the same. So we only have one unknown, so we can figure this out. Using our calculator, we know that 49.5 squared is 2,450.25, and a squared plus a squared is 2a squared. To get rid of the 2 and the 2a squared, we're going to divide both sides by 2, which leaves a squared is equal to 1,225.125. And now to get rid of the exponent, we find the square root of both sides. And using your calculator, you find that the square root of 1,225.125 is 35.0017, which rounds off to 35. So each side of this figure is going to measure 35 feet. And we found the answer by applying the Pythagorean theorem.